exploring the natural world one podcast episode at a time. This is For What It's Earth.
Hi, all, and thank you for joining me for another episode of For What It's Earth. And this mini-series, this is episode 2 of the Climate Change from Sky to Core mini-series featuring Samantha Rebuck. Say hi, Sam.
Hello.
So we are going to be digging deeper into the natural world and focusing on climate change impacts. And this week we are going over climate change and atmosphere. Last week, we talked about general climate change impact, a little bit about the different perspectives and why people should be caring about mitigating climate change, as well as going over some kind of keywords about climate change in general. But this week, we're talking about air, clouds, precipitation, storms. We talked a lot about storms last episode. So this week, Sam's carrying the team with her weather knowledge, making a funny face at me. Okay, all right. But yeah, so enlighten me with like the very basics, because in my head, I know that climate change, human-caused climate change impacts the air temperature, right? That's increasing. And then from there, I start focusing down. So I do not focus very much on what is happening to clouds. Somebody in one of my classes, I was teaching an iNaturalist seminar, and they asked me if there were any photo ID apps for clouds. And the first thing I was like, I truly had no clue. I was like, you want to look at clouds? Okay, all right. But as an educator, I can't say that. So I was like, you know what? I don't know, but I'll find out the answer for you. And I found that there were like, you could take a picture of a cloud and it would tell you cumulonimbus or whatever.
Yeah.
And I was like, wow, this is amazing. It's a whole aspect of natural sciences that I have severely neglected in my education. So tell me a little bit, paint me a word picture, if you will, of how human-caused climate change can impact the stuff up there.
I mean, it all starts up there, that's for sure. I mean, the whole kind of concept of human-caused climate change is from the amount of carbon dioxide that goes into the atmosphere. So that's and builds up in the atmosphere. So that's why our climate is changing. And the amount of greenhouse gases that are up there. Yes, there are a lot of other factors, but if it wasn't for, like you had said last week, with the Industrial Revolution and the introduction of cars and all of the different like generation facilities that we have, if it wasn't for all of that releasing greenhouse gases, so carbon dioxide, carbon monoxide, actually, even hydrogen and oxygen are both considered greenhouse gases. If it wasn't for that, we would not be in this situation, because that is really where it all starts.
Okay. So I know like you have carbon cycling that happens, you know, as things decay, goes into the soil, comes back out, trees, you know, take our carbon dioxide, turn it into oxygen. So that's kind of when I think of carbon dioxide in our atmosphere, it's much more on still very surface level. So when you say it gets stored or it just is up there, is this like in the clouds or even above the clouds?
No, even above that. I should know the terminology better than I do, but there are different levels to the atmosphere, just like we have different levels to the earth in terms of, you know, core, mantle, crust, all of that. We have the same thing that comes up in the atmosphere. So that carbon dioxide is stored high up there, kind of like where people think of the ozone layer. Is like these different levels of gases and where they get stored. And the ozone layer was also the hole in the ozone layer was
right. That's
another thing that a lot of people think of.
So I heard that was kind of repairing itself. Is that true?
Yeah. So actually, this is something I thought of when we were discussing last time. that yes, all these horrible things are happening with climate change, but the earth tends to heal itself. It's happened over many different events that have happened. I mean, I'm sure the earth did not plan on having an asteroid crash into it billions of years ago. But it survived. So that it leads right into the ozone layer. It's healing itself. And the reason for that is because humans discovered, oh, CFCs are causing this issue. We should stop using them. So we stopped using them. And now the ozone layer is healing.
That's awesome. What is a CFC?
They were gases in hairspray and aerosol containers.
Oh.
So now it's been replaced with different types of chemicals.
Other things. Oh, okay. I do remember people being like, don't use hairspray. That hurts the ozone layer. But that was like many years ago that I heard that.
Yeah. That
was
I
was like just like, I have no connection as a small child to why. What does hairspray have to do with the ozone layer? But okay, sure.
Here's some scientific words. Chlorofluorocarbons are CFCs. They are non-toxic, non-flammable chemicals containing atoms of carbon, chlorine, and fluorine, used in manufacture of aerosol sprays, blowing agents for foams, and packing materials as solvents and as refrigerants.
Okay. Wow. Okay, so that was then, as we would spray it, the big words that you said, the carbons, would go into the air, and then they would just keep going up and up and up.
Yeah, and to be honest, I don't know a whole lot about the forming of the ozone layer, probably because it would have happened before, I don't even know the time frame on it. And it happened over Australia. So Americans, of course, we didn't care because, it was not an American thing. But I don't actually know how it interacted with the ozone layer and why the hole formed. But without the ozone layer, we will get hit with more UV rays, which will lead to more sunburn, more skin cancer.
Well, yeah, I thought it was a concern of cancer and radiation.
Exactly.
Which I guess can lead to then a connection to plants because they're trying to eat the sunlight. So they would be radiated as well.
Right.
But we also care.
Yeah, that could change it.
Yeah. Okay.
So that going back to how it affects the atmosphere is so that the higher level of gases that don't belong there, again, greenhouse gases are naturally occurring and they're normally in our atmosphere. But with the amount of increase from human impact is how it's affecting us. To be honest, I don't know how it affects clouds over like just clouds.
Right.
Like we've talked about, it definitely changes storms and the amount and intensity of storms. But it also is affecting the air currents and the way that the storms are moving, which storms move based on air currents and airflow. That is definitely affected as well. And air, not thinking of just kind of surface level air, but there's also obviously air in the atmosphere. These higher level air currents are what's being affected. And then, like you said before, everything filters down and affects everything else below it too.
Right. So these air currents, this is just me having a severe gap in my environmental knowledge, but I know more about ocean currents. Do these air currents and ocean currents, do they kind of match each other in terms of like moving things around the planet?
Yeah, pretty much. They definitely work hand in hand.
Cool. So when you're talking about the storms and those severe weather events, obviously we know about them because they're impacting us directly. Like I'm not up in the atmosphere studying it. But I know about all the crazy snowstorms that we've had, the ice storms, the hurricanes, superstorms you mentioned last time. So what are some of the noticeable implications of climate change? Like, I know I had mentioned as a kid, we had snowstorms, and yeah, maybe once it was like above 3 feet in the Pennsylvania mountains, which kind of made sense. But there weren't these superstorms, or what was there? There was a weird term like bomb cyclone.
Just something Snowmageddon was a big one that they were using.
Okay. But like the names for these things are getting really drastic.
And they are not scientific terms. This is totally from the Weather Channel, and they just are a media source anymore. They are not yes, they provide the weather, but they come up with these crazy names and like naming snowstorms now, like hurricanes.
Okay. So that is truly just media hype.
It is. However, surprisingly, last winter, I did notice NOAA used one of these crazy names, and I can't remember which one it was now, but NOAA actually picked up on it. And so I don't know if that was from like the PR standpoint of using media terms and catching people's eye, or is it a scientific term that now the science community is using?
Wow. Oh boy. Okay. Interesting. So when we're talking about those air currents and they're creating these massive storm events that we've been having, how does human-caused climate change impact storms specifically?
Oh, it's a very big question.
Taking you back to your college years.
Yeah.
Many years ago.
Yeah. And this was, atmosphere was one of my kind of focuses. Atmosphere and geology, surprisingly, the two like opposite ends
the two extremes.
And then you were like right in between.
Yeah.
So the storms are becoming more. There are definitely more storms, and also they're becoming more intense. So that's more of the issue that we're starting to see. And their tracks are not as, what's the word I want to use? Trackable, I guess.
Is it harder to predict?
Definitely, yes. Okay. And hurricanes were always kind of difficult to predict to begin with, but like this, there's a hurricane right now that's coming up to Florida. So hurricanes on the East Coast start off the coast of Africa, and they travel up across the Atlantic and typically they go through the Caribbean, and then somewhere they'll hit the US. And it kind of in typical form, it would either go into the Gulf of Mexico and hit one of the Gulf states, or it would just track up the coast and kind of go off the coast of Maine then. This storm went up and hit Puerto Rico and then made this complete turn and is going like it looked like it would go towards the Gulf. And now it's like, nope, I'm going to cut completely across the state of Florida. So like the tracking of it was like, some people were like, oh, it's going to go in the Gulf. It's going to go up the coast. And then it just didn't do neither of those.
Is that where some of the issues, I think, what was it, 2 or 3 years ago, Texas had a bunch of hurricanes, one after the other hitting it. And that was so like the infrastructure there was not able to support that much rainfall and that much wind.
Yep.
Was that series of hurricanes also one of these just like, what is happening hurricanes?
I don't remember that one being as like weird tracking wise. It was more the fact that there were like 3 storms in a row that hit, and they would hit like in the same spot.
Right.
Which we've seen that happen with tornadoes over the years. A lot of the same places get hit with tornadoes over and over and over again.
Well, that right there is something that has been a very, very clear change. I remember in little kids when we were like reading The Wizard of Oz, and they'd be like, yeah, there's tornadoes out in the Midwest. we're not going to get tornadoes in the mountains of Pennsylvania. That's silly. Pennsylvania itself would never get a tornado. Yeah. And the past maybe 2 or 3 years have had tornado warnings and tornadoes touching down repeatedly. Last year, there was a tornado that touched down and was very, very devastating right where I lived. We were very lucky that the tornado kind of jumped. And so we were over or under one of the places where it jumped. So it was insane devastation on both sides of us.
Wow.
So we were very fortunate that we didn't get hit, but many of the people that we know did. Roofs were blown off. All of the trees, it was so weird to drive down some of these roads and just the trees were all snapped in half.
Yeah.
I didn't leave Pennsylvania, but now tornadoes are like, yeah, we're going to start getting those every summer now, into every fall. So is that also something that we can see as being like a climate change, human caused climate change?
Oh, totally. And actually the term of Tornado Alley, like the geographic area has shifted.
Oh, really?
I don't know if it's shifted in the education world quite yet. Like what I can remember looking at, like a science book with a map of the United States with that red, oval where Tornado Alley was. It now includes parts of Tennessee and Kentucky, Mississippi and Alabama are now included in that as well. And traditionally growing up, it was like Kansas.
Yeah. Kansas, Idaho,
Nebraska.
Yeah.
So that's definitely, and tornadoes, especially you'll see too, that comes from those air currents because people traditionally think that tornadoes are cyclical running perpendicular from the ground, but it's actually air that is rolling, so parallel to the ground that is rolling and hits these updrafts of air currents. That are, so it's like this rolling pattern. Yep. And then when it hits it, it tilts the air up perpendicular, and that's where you get a tornado from, which is interesting because when you look at video of a tornado, it looks like it's dropping down from the sky, but it's just the clouds getting sucked into that air that got split.
So it's kind of invisible until it pulls the visible cloud down.
Exactly. Yep.
Wow. Okay. All right. Definitely not scary at all. No.
Yeah.
Invisible tornadoes. Sure.
Oh, I know. That's what makes it like, because a lot of people, and I mean, I still do it too. You're looking up at the clouds and you see those big anvil shaped cumulonimbus clouds that they're storm clouds.
Okay.
So it starts out really wide, kind of closer to the ground.
Okay.
Or closer to kind of that cloud level. And then it builds upward. And so everyone's waiting because they're like, oh, that's a storm cloud. It's going to drop into a tornado. And that is one of those air uplifts that's pushing the clouds up, which is why the clouds are going up then. And so normal air that's rolling hits that pocket
and
yep.
Oh, wow. Okay. All right. Wow. That's very interesting.
So that's just how tornadoes in general work, which is also why they are extremely hard to predict. And that's not even a climate change issue. That's just the loveliness of tornadoes.
Right. Okay. That's just how air works. But then I can imagine if our air currents are being impacted in such an extreme way that we would have more of them because there's more of these weird air pockets that are sucking everything into the sky.
And so another kind of the line between warm air and cool air, which would be warm fronts and cold fronts. So if you watch the weather, you'll hear them talk about that. And so one goes one way, one goes the other way. And when they meet in the middle, that's when you get these fronts that often cause storms. So obviously, with human-caused climate change, you're having more mix of these different air currents. Like the air currents coming up from the south are hotter, and the currents coming down from the north are colder. So the more intense of a difference between the two temperatures, most likely the more intense that front line is going to be with storms.
So when you say intense with storms, does that mean that the individual storm is that much crazier, or they are more frequent?
It could be both.
Okay.
It could be one, it could be the other, or it could be both. That's what we've been seeing, at least. I don't think there's a good enough answer to say one or the other.
Great. So then another thing that I'm seeing is that even the lows, like, in summer you get your summer storms. That's just normal. And in spring you get your nice, cute spring rains, very refreshing. You get your wonderful snow melt. It makes the rivers rise, lovely. And then in summer you get your thunderstorms that don't actually produce any rain. It's just thunder up there. And then you get your crazy storms. But I've been seeing extended periods of drought as well, where there are no storms at all. So this summer was a pretty bad drought in Pennsylvania. I know much of the eastern and into northern portion of this state was beyond just drought watch and into the, yes, we have a drought. It is official. Everybody do not use water, do not irrigate your lawns, anything like that anymore. And it was really pretty long this year. And every year I've seen an increase in the time length of us having droughts. So if the storms are more severe, how does the air current impact then where the storms kind of get deposited, and why are they missing certain areas?
This is going beyond my atmospheric knowledge.
Okay.
And it could also be the time that I've been out of the academic world. And at least when I was in school asking these kind of questions, the answer we would get was, I don't know. Scientists don't know.
Oh,
and so,
okay.
That still could be the case.
Right.
It's one of those things that we continuously are trying to learn about. And it doesn't help that for all these years, the term climate change and saying you were a climate change scientist, like,
right,
you weren't getting funding to even do the research. So
right,
scientific research takes a very long time.
Yes,
and so
many years.
When it's really just starting, I think that definitely causes pockets of misinformation. However, I'm sure an actual atmospheric scientist could probably answer that better than I could.
Well, that's totally fine. You don't need to know everything in the world. It's all good. It's all good. But I think that right there is something that should really get us to realize how fast this is happening, because you're saying, oh, well, this is probably how long I've been out of school. In a human's life, we haven't been out of school that long. Like, I graduated 2014. You 15. Were 15. Yeah. We haven't been out that long. It's 2022 when we're recording. So it's been like 8 years, 7 years.
7 for me. Yeah.
Under a decade since we graduated our undergrad. And maybe you had more atmospheric classes, but still like 10 years max. And this is how much information is changing, how much science has been able to do research, which is good in both ways. You can take it as encouraging. Like last episode, we were saying that, what will happen 50 years from now, we can't even predict because new information is being found and scientists are doing so much more. But it's also like climate change is happening really fast, human-caused climate change.
Right.
And I know when you're saying you've been out of school with this atmospheric stuff, there was a graph I remember, or a diagram I remember seeing in one of my general wildlife classes that was looking at the prediction, I think from the Paris Climate Accord for 2050, and what they thought was going to happen. And we have surpassed that
Oh, yeah.
by far. And that was a prediction that they made, being like, yeah, this is 2050. That's still 30 years from now. And it is already incorrect information.
Right.
And we definitely need to be addressing this now, but it's also the fact of we needed to be addressing it a very long time ago as well, because it is changing really fast. So how do we kind of balance that knowledge of like, we're not working fast enough, but we also need to realize that we are learning still?
I think that's just a general understanding of science, and the understanding that sometimes scientists are wrong and hypotheses get proven wrong. And that is
part
acceptable.
Of science. That is a good thing because it spurs further discovery.
Exactly.
Yeah.
When scientists say something, it should not be taken as absolute, and this is the way it will be forever.
Yeah.
When they say something new in 2 years, you need to be able to, as just kind of a normal person, be able to accept it and say, okay, they now discovered in 2 years things have changed, and so we have a different idea of it now, and that's okay. And to be able to accept that change for what it is, which as human beings is a very difficult concept.
Right. Change is hard.
Right. And when the people that you're being told to trust change, I think that's even harder.
Right. Yeah. I've never thought of it that way, of like the people that we're trusting to provide us with accurate information. In a year from now, I say something different, which for you and I is very normal because we're coming into this with a scientific background. We understand our hypotheses and our null hypotheses, and we're trying to disprove this and what a theory is and all that. But for the general populace, that's just being strung along and teased and then lied to.
Yes. Which, going along with our atmospheric theme of today, is the general thought of meteorologists in general, that they're always wrong. There is this idea of, actually, I just heard someone say this a few days ago. Whatever the weatherman, the term that was used, whatever the weatherman says, I believe the opposite. And
I hear that a lot.
What happens.
Yeah.
And it's horrible because meteorologists are extremely smart. They go through years of calculus and physics and a lot of information. And to be a weatherman on TV, you typically need at least a master's degree in meteorology or atmospheric studies. So they know what they're doing, but weather is weather, and it will change. And that's the difference between weather and climate. Climate is going to change, as we've seen, at a more slower pace. I'm going to
it is changing over years, not over seconds.
Right. Weather is, no one knows where this air current is going to go in the next 2 hours. I can predict it. They have all these amazing models out there.
Right.
But we just don't know.
Right. And I still, sometimes as a scientist, I still find myself being like, so the weather says that it is going to rain today. It hasn't rained at all.
Yep.
So I'm not going to plan on it raining, even though it says it's set, so I do that too. I know. But there are times where I'm like still blown away by the fact that I can just, when I get up in the morning, pick up my phone and have a general idea, even if it is not pinpoint accurate. I still know, okay, there's a chance that it's going to rain today, so I'm going to bring my jacket, but I see that, I don't need to be like freaking out and be like, batten down the hatches sort of craziness. And I know that I should wear a t-shirt instead of a long sleeve shirt. And I can have that idea at my fingertips. That to me is still very astonishing. And I think that we definitely hyper focus on the ways that meteorologists are wrong.
Yes.
We do not give them enough credit for all of the incredible help that they have been.
Yes, exactly.
So props to all the meteorologists out there. I apologize for occasionally being one of the crazy people who doesn't give you enough credit.
I totally do it too.
But yeah. So then as we're looking at all these storm events and being able to, you're saying about your in-laws before, living on the coast and seeing the storm events and how that impacts their land situation and how we have a lot of ice storms around here now, which impacts the forest health and all that. Are there any, and this is truly not me just trying to stimulate the conversation, but truly, I don't know this. But other than hairspray, you're telling me that one, are there things that we can do that specifically will impact weather in a positive way? And maybe like it's not going to be noticeable because we are very small compared to the atmosphere, but like the not using hairspray with CFCs in it, how that impacts the atmosphere. Like,
right.
Are there other things too that we could be doing that we're just not doing because us little people don't know?
That's an awesome question. I don't actually know of anything that specifically will impact the atmosphere. And I want to say it might partially be because it's one of those things that you don't see the effects of until it's like really bad, like the ozone, the whole ozone layer. Like we didn't know it was an issue.
Learned about it.
Right.
Gotcha.
That is something I'll need to check into.
Okay. Interesting. Because I can imagine as that general ecologist, like everything, because everything is so interconnected, like eventually it'll work its way up. But at the same time, I'm just like, no, I want to know about the hairspray. I want to know, like, okay, single-use plastics has direct impacts on the Great Pacific Garbage Patch and stuff like that. But what has specific impacts on the atmosphere? Because like you're saying, it's all going to be trickling down. If I'm going to be a steward of the earth, I need to be a steward of the whole entire earth, not just what I can see, but what is above me as well.
Exactly. I guess, renewable resources. So solar panels, wind turbines, using these renewable resource energy sources would help bring down the amount of greenhouse gases that we are emitting into the atmosphere.
Yeah.
While yes, we still typically need some sort of turbines to create the energy that we're collecting from the sun or the wind or whatever other resource you're using, but the amount that you need for like a solar field is significantly less than you'd need obviously to run a gas
refinery.
Like yes, where's the word refinery? Or to obviously run a coal plant.
Gotcha. That's a really good one because I think one of the things that I really appreciate here in Pennsylvania, southeastern Pennsylvania, our power supplier is PECO. When I was in the mountains, it was
PPL.
Yep. So there are different suppliers, but something I've really appreciated about PECO is you can choose where you want to get your electricity from. So even though I, as someone who is renting, I can't put solar panels up. However, I can select that my power comes from a wind generator.
Exactly.
And so I really appreciate that I can select that, even though I physically cannot do the installations myself. One day I really want to do solar on whatever house I have. But I know
We've been talking about it.
Yeah. Oh, that's awesome. Yeah, because you have a house now.
I do. And and we're in an HOA. So on our walks, we're in like other associations. And I'm like, hey, they have solar panels. Are we allowed to have solar panels?
I know that's an issue with HOAs.
It is. Ours is, we're in a pretty good HOA. Nice. I removed a bush, like a really big, dead, ugly bush from my front yard, and no one complained. So
that's
I think
great.
we're good.
Nice. Yeah. It's remarkable. What sort of like garden? Oh, I lived in an HOA at one point. I was renting a house there, and I got fined for my curtains were too colorful. And I was like, listen, I like color. Okay. And then I got fined because I was overwintering my perennials. And so I specifically wrote back and included scientific scholarly articles of why I was overwintering my perennials. And then they were like, okay, you don't have to pay your $100 fine. But I was like, what is this madness? So I know that HOAs can be an issue. So that's really nice that you might have that feasibility. Awesome. Well, that's really good to think of. Because that wasn't a direct correlation that I had in my head. So
yeah, I needed a minute to think about it.
Yeah, no, but I appreciate that you did. So for what it's worth, everybody who can be more conscientious about what sort of energy that you're using, and again, even if you don't own, think about where your power is coming from, and maybe reach out to your provider to see if they offer different sources of, I know that I could choose from hydro or wind, or just a like greener sort of energy provider. But you can check that out, give them a call, see what they have available, and make that switch if that is something that you could do, because that would, make the world a little greener, and that would be great. So with that, thank you for digging deeper into the natural world with the Art of Ecology and with Sam Rebuck. If you enjoyed this week's episode, you can go and review and continue to follow along. Next week, we will be talking about a step down from the atmosphere. We started talking a little bit about storms and rain, and I made mention to the ocean currents. We'll be talking more about climate change and oceans, which Sam and I were very into marine biology, so I can imagine that will be a really good episode you will want to stay tuned for. So Sam, anything to plug?
Thinking about when you look at your weather forecast, this is like a plug of knowledge that a lot of people don't know. When it gives you the percentage for rain, that is not a percentage of, there's a 30% chance in the day it's going to rain. It just means when the conditions have been like this in the past, 30% of the time it rained. So most people see that as like,
there's a 30% chance it's going to rain today.
Yes. That is
not
how to think about it. Yep.
Wow. My mind is blown by that fact. I didn't know that. That's so cool. Thank you.
So that percentage is like, when you wrap your brain around what that actually means, it's a less chance than you probably think it is. Right.
Yeah. The fact that on a day like today, it rained 30% of the time in these conditions, that does not seem as high.
Scary. Yeah.
Yeah. Wow. Okay.
Yeah. Tidbit of knowledge.
That is a really good tidbit of knowledge to have. Super cool. All right. I'm gonna plug something cool too today. Then, because I feel the need to compete with you. As we do.
It is your podcast. I feel like you should win.
No, I mean, you are a permanent guest now on this miniseries, so it's we. but yeah, I just, ever since childhood, I've had to compete with you, it is what it is. So I'm going to plug Cloud Spotter, which is the weather ID picture app that I found for my little class. And it looks really cool. It is advertised as being able to identify clouds as well as light events. So I thought that was really interesting. You could take a picture of a rainbow and it would tell you about the rainbow, or you could take a picture of the corona around the moon, I believe it is, and it would tell you more about that. And on their website, cloudspotter.org, I believe, it goes and there's a series of TED Talks by the founder who goes into a lot of information about meteorological events and the AI that was developed to identify these things. So it was really cool. It was a little above me, but it answered my students' question. And I thought if I were to get more into observing the clouds, that could be a really cool tool to have in my back pocket. So check out Cloud Spotter. Cloud Spotter is the app. If you search that in the App Store, it is free to download. I have an Android. I believe my student had an iPhone, and that was totally okay. So if you go and search Cloud Spotter, and I'll also put that in the podcast description as well. Yeah. Wow. Thank you so much. For more tips and eco inspiration, you can check out my website, www.theartofecology.com. You can also find me on Instagram, Facebook, and YouTube. And with that, I will see you next time for episode 3 of this mini series, where Sam and I talk about climate change and oceans. Bye, y'all.